Black holes, they're probably some of the most mysterious, most talked about objects in the entire universe, right? Well, today, we're going to pull back the curtain and demystify them. We'll explore exactly what they are, how they work, and most importantly, why that whole idea of them sucking things up is just plain wrong. Let's dive in. First things first, let's just bust the biggest myth right out of the gate. You've seen it 1,000 times in science fiction. Black holes are these roaming monsters gobbling up everything in their path like some kind of galactic vacuum cleaner. But is that what's really going on? Well, the answer is a big no. A black hole's gravity is incredibly strong, for sure, but it isn't some magical, far-reaching suction force. From a distance, its gravitational pull is exactly the same as any other star or planet with the same amount of mass. So, get this. If our sun were to just poof and be replaced by a black hole with the exact same mass, Earth would just keep on orbiting it like nothing happened. I mean, it would get very, very cold, but we wouldn't get sucked in. So here's our roadmap for today. We'll start with the basics, what a black hole actually is. Then we'll get into their dramatic birth stories, check out the different sizes they come in, and look at the amazing ways they bend the universe around them. We'll even imagine a trip to the point of no return, and finally, we'll figure out how we find these things when they're totally invisible. Okay, so what is a black hole? First off, you gotta forget the idea of a hole at all. It's not empty space. It's an absolutely massive amount of stuff crammed into an impossibly small area. This creates a gravitational field so powerful that absolutely nothing can escape it. To really get this, we have to kind of rewire our brains about gravity. Thanks to Einstein, we know that gravity isn't really a pull. Instead, massive objects bend the very fabric of the universe, what we call space-time. Think of it like a stretched-out rubber sheet. If you put a bowling ball on it, it creates a deep dip. Any smaller marbles rolling nearby will curve toward it. Well, a black hole is like putting something so heavy on that sheet that it creates the deepest well you can possibly imagine. This extreme curve creates a boundary, a one-way door called the event horizon. Once you cross that line, the speed you'd need to escape is faster than the speed of light. And since nothing in the universe can travel faster than light, there's no getting out. It's the ultimate point of no return. And that's why we call it a black hole. It's literally a prison for light. All right, so if that's what they are, where in the world do they come from? It turns out their births are some of the most violent and spectacular events the cosmos has to offer. The most common way you get a black hole is from the death of a truly enormous star, one that's at least 20 times more massive than our sun. For millions of years, this star fights a battle between its own gravity trying to crush it and the nuclear fusion in its core pushing outward. But eventually, the fuel runs out. Gravity wins. The core collapses in on itself, triggering a titanic supernova explosion. The outer layers are blasted away, but if the core that's left behind is heavy enough, nothing can stop gravity from crushing it down forever, forming a new black hole. And here's the thing, once they're born, they don't just sit there. They can grow. A black hole can pull in gas and dust from its surroundings, or even from a nearby star, in a process we call accretion. Or, and this is one of the most powerful events in the cosmos, two black holes can actually spiral into each other and merge, forming an even bigger one and sending massive gravitational waves rippling across the universe. All this growing and merging means that black holes aren't all the same size, not even close. You can think of it like a cosmic family tree, with different branches for different types. Scientists basically put them into three main categories. First, you've got your stellar mass black holes. These are the common ones, born from single stars, and they can be anywhere from a few to maybe 100 times the mass of our sun. Then you have the absolute titans, supermassive black holes. These giants are millions, sometimes billions of times the mass of the sun, and we think there's one at the heart of almost every big galaxy, including our own Milky Way. And floating in between are the elusive intermediate mass black holes, which are still a huge puzzle for astronomers. Okay, so we've busted the sucking myth. But what do they actually do? Well, by warping space-time so intensely, they become these incredible cosmic engines, creating some of the most extreme and energetic shows in the universe. When matter gets close, it gets caught in this gravitational dance, forming a swirling, superheated whirlpool called an accretion disk. The friction and speed in this disk heat the material to millions of degrees, causing it to glow incredibly brightly, lighting up the area around the black hole. Sometimes, magnetic fields then grab some of this material and funnel it into colossal jets of particles that shoot out from the poles at nearly the speed of light. Their gravity also produces two really mind-bending effects. First, it's so strong it literally bends the path of light that passes by, acting like a cosmic magnifying glass. We call this gravitational lensing. And second, and this is where it gets really weird, they don't just bend space, they bend time. The closer you get to a black hole, the slower time ticks for you compared to someone watching from far away. It's called time dilation, and it's one of the wildest but real consequences of Einstein's theories. All right, let's get to the question that's on everyone's mind. What would really happen if you ignored all the warning signs and decided to take a plunge into a black hole? Well, let's just say it would be uncomfortable. It's not like jumping into a pool. As you get closer and closer, gravity starts to act on you in a very strange and very, very uneven way. And scientists, believe it or not, have a fantastic name for this: spaghettification. It's a real term. See, the gravitational pull on your feet would become so much stronger than the pull on your head that you'd be stretched vertically and squeezed horizontally, just like a long piece of spaghetti. With smaller black holes, this tidal force is so extreme it would tear you apart before you even crossed the event horizon. So, if they're invisible, and anything that gets close is, well, spaghettified, how on earth can we be so sure they even exist? It's a great question. We can't see them directly, but we can see the massive footprints they leave on the universe around them. But before we get to the solid proof we do have, let's touch on a fascinating theoretical question. The great physicist Stephen Hawking proposed that, believe it or not, black holes might not be eternal. He predicted a very strange quantum effect now called Hawking radiation. The gist is that black holes might be able to very, very slowly leak energy back out into space. Now, this is still a theory, but it suggests that over unimaginable lengths of time, trillions upon trillions of years, a black hole could slowly fade away and completely evaporate. Okay, but back to the hard evidence we can actually observe. The first piece of concrete proof was something we heard, not saw. In 2015, scientists made a breakthrough. They detected gravitational waves, actual ripples in the fabric of space-time. And what caused them? Two black holes that had spiraled into each other and merged a billion light-years away. The little chirp signal they recorded was the sound of space-time itself ringing from this cosmic collision. It was incredible. And then, in 2019, science gave us this: the Event Horizon Telescope, which is basically an Earth-sized network of telescopes all working together, did something nobody thought was possible. They took a picture. Not of the black hole itself, but of its shadow, the dark void silhouetted against the bright glowing gas swirling around it. This is a real image of the point of no return at the center of the M87 galaxy. So, let's do a quick rundown. Black holes do not suck. Their gravity is totally normal from a safe distance. They're born from the spectacular deaths of giant stars and come in all sorts of sizes. They're the true masters of space-time, creating brilliant accretion disks, powerful jets, and even bending light. And while they're invisible, we know they're out there because we can hear the ripples they make in space-time and see the shadow they cast against the cosmos. There is so much more to talk about here. So what do you want us at Curioverse to dive into next? Should we tackle the bizarre, time-bending physics near the event horizon? Or maybe unpack the secrets behind those colossal jets? Drop your vote in the comments below and make sure you subscribe so you don't miss our next explainer.